Okay, so hello everyone. Thank you for joining today's webinar. Thank you, Stephen, for agreeing to be our host today. Stephen Harley is a senior marketing consultant working in Huawei, Western Europe marketing team. For 25 years, Stephen has provided strategic advice to the world's leading telecoms and digital economy companies, helping clients across the ICT ecosystem to understand and benefit from future opportunities in broadband, mobility, and digital services. Stephen's focus is particularly on 5G go-to-market strategies, carrier strategies, and disruptive forces in Western Europe. And today, Stephen will tell us a bit more about the Huawei Intelligent World, which I think is interesting to everyone who is interested in the ICT industry, its future trends, and basically interested in future tech and how this world will evolve from it. Yeah. So thank you all for joining. I will mute your microphones. You can use the chat box to write your messages if you have any questions, or in case you cannot hear Stephen clearly. Please use the chat box to tell us. And now I will let Stephen take over. At the end of this presentation, we will also have a Q&A session. As the last time, we will reward 5 of the participants in the live webinar, and also we'll offer 5 more rewards for those who participate in the forum Q&A session. Those of you who are already familiar know that at the end of each webinar, we present 3 questions, which will be posted in the forum webinar post. I will share the link again here in the chat box. So you can reply the 3 questions and receive a $20 Amazon gift card. 5 lucky winners will be chosen, and also 5 of the participants in the live session will be rewarded here in the live meeting at the end of the presentation. But more about that after Stephen's presentation. Now I will stop speaking. Thank you.
That's okay. Well, thank you. Thank you everyone for taking the time out as well to come and listen to us. And yeah, just by way of introduction, I sit in our Western European marketing team, which is actually based in Dusseldorf, which is the background that you can see behind me. Actually, it's a hell of a lot more glamorous than the UK today, and certainly a lot sunnier too, judging by what I can see out the window. So without further ado, let me share my screen and I can hopefully talk you through what we've been up to with regards to the world of 2030. So this is an ongoing series of research reports that we've been delivering over the last few years now, just really giving our view of how the world is going to evolve, and importantly, for us at least, the role of technology within that. And the way it's been built up is really through some very thorough research, lots of interviews with futurologists, with academics, lots of workshops with those involved in technology and how it's going to evolve moving forward. And what I'm going to do throughout the rest of this presentation is just we'll spend about 45 minutes or so just going through these high level outlooks, those 8 that you see there, and just really what I've tried to do at the end of this presentation is kind of look at them from a more of a technology lens rather than from an issue lens. So at the end you can hopefully we'll make it nice and clear how the technology enables a lot of these things, and how actually one set of technologies can actually enable several things and support several developments as we move forward. On the left there, you'll see a link. I would recommend you go there to download the report. It goes into a lot more detail that we're going to be able to do this morning. And there are also a few satellite reports in particular looking at some of the technologies as well, which you may find of interest as well. So there's a lot to unpack this morning, and there's even more to unpack in the reports too. And as I say, if you want to go and investigate a little bit further, I would recommend it. Not only is there more detail on what I'm talking about, there's also lots of references. So it's a really good starting point to go off and do your own exploration of what the future may hold. So those 8 outlooks that I mentioned, you can kind of see really from here that they're quite high level. They link quite closely to the UN sustainability goals. So as we go through all of these, a lot of the premises that we're starting with are the challenges facing the world as we move to 2030, and then how technology is looking to support meeting those challenges. Okay, so without further ado, let me dive straight into our first one. And in terms of healthcare, there's several different ways and approaches of looking at this. But I think it's really this prevention, precision, and telemedicine pretty much sum up the idea. So one of the key issues the world is facing over the coming few years is going to be an aging population. So about 16.5% of the world's population will be over the age of 60 by 2030. At the same time, the World Health Organization is also estimating that there'll be about 5.7 million shortfall in nursing staff and about 18 million in healthcare workers in total by 2030. And at the same time, the World Health Organization are also showing that about 60% of illnesses are actually caused by lifestyle factors. So here we have an aging population, a shortfall in labor, and actually lifestyle really being one of the key determinant factors of how we look after ourselves. So how does technology come into that? Well, if we start on a diagram here on the right-hand side, we start on the top left-hand side there, it's really about moving towards that proactive healthcare and actually trying to prevent as much as we can. So if we imagine that the rise of wearables and IoT, this enables us to track and monitor our health. Now, of course, those sensors can become smaller and more accurate and can take readings in places of things that we're only just imagining right now. So we can collect huge amounts of data to understand what's going on and then use technologies like artificial intelligence to understand what is the best proactive prevention lifestyle change that you can make in order to prevent that becoming a bigger issue. And we've seen it over the last year or so with regards to COVID, but actually using things like natural language processing to track diseases. So actually tracking mentions of symptoms and diseases and understanding maybe where they may be developing. And again, getting in there first and fast. Now, underneath that, we kind of have the reaction to if something does go wrong, using precision to really deliver a tailored solution to the patient. So people react to medicines in different ways and different doses. They can or can't have different things. Some things will react in different ways with each other as well. So using AI to really personalize the treatment of medicine, and also using AI to understand exactly how to maybe target treatments. So a really good example of that is things like cancer diagnosis and radiotherapy treatment thereafter. Using AI to identify exactly where the radiotherapy should be targeted. And you can actually then reduce the amount of healthy cell damage by about 30%. So really being able to use this technology to understand how to deliver that medicine. And if we're talking about delivering healthcare, then that brings us to the last diagram on the right-hand side of this diagram, which is the home spital. It doesn't really trip off the tongue, but it's the notion that actually healthcare can very often be delivered better for the patient and more efficiently for the healthcare provider if it's done at the home. So going back to that notion of sensors and IoT, we're able to collect a lot more information. We're able to monitor a lot more information as well. Just to give you an idea, things like handheld ultrasound scanners, which can obviously deliver that service on a mobile basis, can cost a few $1,000s, as opposed to a hospital machine, which can cost $100,000. So you're really democratizing and making available a lot of the technology. And if you consider that in more rural areas, then actually being able to take that machinery and make it more portable also makes healthcare services more widely available, certainly to a lot wider population across the world. It's not just in the richer countries where we can stay at home. It's actually about bringing treatments to people that currently don't have access to them. So with mentions of AI, you may be wondering, why do we have things on the left-hand side talking about computing power? That enormous amount of data we will keep coming back to. The need to process that data we will keep coming back to. And the role of AI computing within that we will keep coming back to. So really we're setting out our stall early here on the left by saying this is a huge amount of computing power that's going to be needed. And just to give you some idea, a zettaflop is 10 to the power of 21 floating point operations per second. So operations per second in computing power will increase by about 500 times. That's one of the key takeaways when it comes to AI. When it comes to general computing power, you still need that general computing power. Let's call it more basic for the sake of simplicity. So huge computing power to power this digital revolution in healthcare. And a lot of these other things that we'll talk about as we go through, really important. And coming back to those UN Sustainable Development Goals, food is a really important one. The UN has a zero hunger goal. However, environmental change is reducing the amount of arable land around the world. Urbanization is actually creating a labor shortage in food production as well. So we're not going to be able to meet that target and our food production needs if we just carry on doing more of the same, using traditional farming techniques. It's just not going to happen. To give you some idea, by 2030, the availability of arable land per capita will actually go down by about 43%. So it gives you some idea of how the traditional methods aren't going to be sufficient to meet our needs. So where does technology come into it? Well, on the left-hand side of that diagram, you can see they're using accurate data rather than just experience. And this comes back again to sensor networks. So actually having a really dense network of highly accurate sensors, checking for things like soil moisture, soil temperatures, acidity, that sort of thing. Really making sure that the soil conditions are appropriate for the plants. You can see that there's a drone monitoring, making sure. We've been working in Brazil, for example, on testing actually not a flying drone, but a land-based drone that is able to go out and autonomously detect weeds, for example, and then remove them within the plants, for example. So there's lots of things going on where we are, let's say, digitally transforming farming. And I think on the right-hand side of that diagram, you see this notion of vertical farms, which is really digital transformation of farming. And so the key here is, as you can see, you're able to create the optimal conditions for growing food, but you're doing it in an environment that enables you to optimize the space. So rather than the 2D farm, let's call it, it's three-dimensional. You're not necessarily using pesticides or even soil. You're reducing water consumption. That can be about 10% of if you're watering a wide area. There's no impact from the outside climate. So this could be ported to Saudi Arabia, to Siberia, to the Mediterranean, to Africa. It really doesn't matter. The same techniques and same technologies can be used. And again, what you're doing is you're using high precision data to understand exactly how that food needs to be grown and making sure that you can optimize the output. And to give you some idea, if you have a 7,000 meter square, let's call it vertical farm, and you were to harvest it every 16 days, you would end up generating about 900,000 kilograms of vegetables per year. So that's a significant amount and significant efficiency in the use of space and land areas, particularly when we come on to some of the other situations like densification of populations in cities, for example. And then last but not least, we start getting to what I would call the more Star Trek type of approaches, which is to look at 3D printing meat. Now, we know that animal husbandry and meat consumption is a big contributor to CO2. We also know that the demand for meat is going to increase. So by 2050, it's going to go up by about 70% from today's level. So actually, in terms of the printed, 3D printed organic matter, it is actually a genuine solution to make sure that we can feed ourselves and meet that demand in an environmentally conscious way. So interestingly, when it comes to beef in particular, the price of 3D printed beef is actually coming up close to animal produced beef, animal reared beef. So you get some idea that actually the quality is improving. Now we're talking about 2030 here. There is still a while to go. It's not necessarily something that you're going to want to do right now today, but as we move forward, it's really important. And then you start thinking about the remote production, and obviously an intelligent connected machine, this robot here actually doing the printing. So coming back to a couple of these enabling technologies on the left hand side, underpinning this and many others, we mentioned about the importance of data and understanding what's going on and collecting all of that data. So you can see there a yottabyte of data generated annually worldwide. Now, to give you some idea of the scale of that, that is a 1 followed by 24 zeros, bytes. So 1 and 24 0 bytes. That's huge. Now, to give you some idea of what that would mean in today's world, if you were to cover the states of Delaware and Rhode Island in the US with 1 million data centers today, that's how much data we're talking about. So it's an extraordinary amount coming from all of these different sources that we're going to see. And you can see the increase there as well. We've talked about rapid data growth over the last few years. Well, you can see it even increasing even further from actually an accelerating base. And that number of connections is important as well, 200 billion connections worldwide, because that talks about the densification of these sensors and this sensor network. Lots of things being connected to the internet to deliver all of this data to make sure that we can efficiently produce this food. And IPv6 adoption is, again, all about the densification of connections within the network. Current or traditional, let's say, IP approaches just won't enable enough devices to connect. Okay, so now we start coming on to our homes and how they will be impacted as well. So there are sort of several ways of approaching this. Probably the most headline attracting approach at the moment is to think about net zero carbon buildings and the climate impact of buildings. So in 2019, the CO2 emissions from buildings accounted for about 28% of the total. And when we consider things like urbanization, that actually the world's building stock is set to double by 2060, you can see that actually making buildings efficient is really important as we move forward. So this again comes back to our sensor networks, where within a building we can understand what's going on in real time and then use artificial intelligence to adapt the settings of that building for what is going on. How many people are there in there? What part of the building are they in? Can we adjust the heating accordingly, the lighting? Maybe we can shut down the power going to a lift if nobody's on that side of the building. And actually, there's a really good example in Australia of where you can use this sort of approach to really make a difference. So there was a museum in Australia that has used about 3,000 sensors and managed to reduce their greenhouse gas emissions by about 35%. and actually reduce their electricity costs by 32% in the same time. So, these are real tangible benefits for doing this in terms of smart homes, which is actually something that people really buy into. Give you an idea, in the UK, 80% of consumers are aware of smart home technology already. So there is an appetite here that can be served and that actually has a greater good as well. So in the middle, we'll come down to the next layer and we're talking about this adaptive home environments. And this is sort of taking that another layer, really, where it's not just the building managing the environment, but it's your living environment adapting to your needs. So it could be, for example, humidity, temperature, lighting, air filtration. All of those things can be personalized for you, whereas next door may have something completely different. And within your household, it could be that the settings are slightly different based on what you want. And you're going to be able to interact with your home in many more ways, much more fluid ways as well. So touch screens, voice like we do today, but also gestures, actually making sure that we can adapt these environments really quickly and easily. And then last but not least on here, we come to a really interesting idea, which is this notion of the infrastructure that we're providing for our needs in terms of TV and to the home, but actually that going so much further. So by that, an interesting example is in the US, an average home is supposed to have about 300,000 items, 300,000 things in it. And actually about 1 in 10 people in the US rent off-site storage. There's just not enough room to put our stuff. And that stuff isn't necessarily something that we use all the time. It may not even be stuff that we use very often. Imagine something like a drill or a tool, for example. Maybe you had to buy it for a particular job. It just sits there for the next however many years until you realize you don't use it. So what about if we could put those things off-site, but actually have very sophisticated ways of recalling them when we need them? There may be some of those things that we own, and there may be some things like a drill that we don't own that are shared on a more community basis. And we have our robots order picking, bringing those things to our door. But actually, we can actually take it even more sophisticated. So you'll see in a diagram on the left there, there's a lady just looking in a mirror. But this is a holographic mirror. This is an augmented reality mirror that is showing the items that she has stored. And she can choose what she wants to wear on a night out. And of course, you can see our little robot along the bottom there, bringing it to her. So this infrastructure needs to have quite sophisticated interfaces at the user end and quite sophisticated delivery mechanisms at the other end. But actually, it does make a lot of sense when you start thinking about it. And to power that, to power things like holograms and augmented reality, you need these big links. To power these deep sensor networks, you're going to need big links. So you can see on the left there, another enabling technology around fiber broadband, and actually the number of homes with 10 gigabits per second speed. I'm in the UK, there's not that many homes with 1 gig right now. Now we're talking about 10 and the need for 10 as well. So to connect all of these things together, to deliver a fast, seamless, smooth service, to interact in an engaging way, you need this underlying technology. So if we, I suppose, scale up our living environments into cities, we talked about urbanization, and about 60% of the world's population will be in cities in 2030. And actually at the same time, there will be about 43 mega cities with populations of over 10 million. So we need to get much better at managing that environment and understanding how to operate, how to function within a city efficiently and effectively as we move forward. There are currently about 1,000 smart city projects that have taken off in various places around the world. What we see by 2030 is those coming to fruition and actually joining together in a much more fluid way. So the first thing really to note is this digital infrastructure. So cities are responsible for water and electricity, gas, making sure that those utilities are delivered. But actually moving forward, there also needs to be an awareness that there is a responsibility for digital infrastructure at the city level. And that consists of 4 layers. So you have sensors, which again, they can be nanosensors detecting things like atomic particles in air, for example, or more sophisticated things like a dustbin is full, it needs collecting, or light bulbs have gone, for example. You need that connectivity again. We keep coming back, you have to keep connecting all of these sensors. You then need a brain, a hub in the center to process all of that data that we keep coming back to, using artificial intelligence, which we keep coming back to manage that. And then you need applications on top of all of that people can actually use to access all of that intelligence that you have. And what that enables you to do is actually, for the governments, is actually run their services in a much more effective and fluid way. And taking that a step further, making the cities more human, making it much easier to interact with city governments. So things like digital IDs, digital credits, all of that sort of thing. And using that intelligence we've got from our digital infrastructure. So for instance, there are various activities going on around the world to monitor the growing elderly population, which may be on their own. And so you can use, for example, water consumption. If the water consumption drops below a certain threshold, you could trigger somebody just to go and check and make sure they're okay. So, just interacting with this data is really important as well. And actually interacting with that data is also important for our last point here, which is about environmental governance. So that is things like water management, air quality, making sure that cities can really meet these targets for their citizens. But also, as our little diagram is showing here, just in terms of waste recycling. So in the EU's Green Deal, about 2/3 of municipal waste has to be recycled by 2030 and 75% of packaging. So managing that volume of waste in an intelligent way and an efficient way becomes really important. And our example here is AI-controlled robots that are able to use computer vision and pick out different items and sort them appropriately for recycling. To give you some idea, in South Korea and also in Malaysia as well, they're using sort of underground low-pressure pipes where you can put waste and it then gets taken for sorting. So a lot of work being done for that as well. And again, in terms of underlying principles of how this gets enabled, we've talked about a lot of them already. Another one to add in here is about 10 gigabit Wi-Fi network penetration. So we talked about 10 gigabits going to the home, but of course Wi-Fi can be a bottleneck if it doesn't keep pace. So in businesses, you're going to need Wi-Fi as well. And that's another thing to pick up on this. We've talked about fiber, we've talked about Wi-Fi. We'll come on to more technologies as we move through. It's the complementary nature of those technologies that's really important as we move forward as well. So our next one is looking around transportation. So how do we move around within our cities, between countries? And there's obviously a really big drive for electric vehicles. But before getting to that, I'm just going to come to I suppose, an important layer that sits above that. And that's this notion of connected vehicles. Really, really important. If you want autonomous driving or you want autonomous navigation, because this can apply to different vehicles, you need that connectivity. You need a lot more sensors to understand what is going on in that around the environment. You need high definition cameras, you need computer vision, you need that processing. You're generating a huge amount of data. So connected vehicles really important. And we've got an example there as well of how you can use those sensors to make things like aircraft design a lot more efficient. So actually, running them on electric, redesigning with these sort of mono wings to really make sure that they're consuming less energy, making sure that they're not grounded and being used efficiently, making sure that maintenance and things like that can be done at the right times. So that's quite an important one. And we've also got there as well our electric flying taxi. That's another area that is definitely going to start picking up. And you can also imagine that being used, for example, in emergency services, which is a great idea. But then in the top left of this diagram, we have a satellite. What's that doing now? Well, low Earth orbiting satellites are going to become important as part of that complementary infrastructure that I mentioned, making sure that we can cover the actually 94% of the Earth's surface, including water, obviously, which is not covered by mobile networks, because mobile networks tend to be where people are. Well, now we're talking about where things are and where things are moving in this case. So we need to make sure that we have that coverage. And it's really important to note as well that we have that seamless handover between all of these different technologies. You know, underneath our satellite, we have a 5G tower. So we need 5G to work with that low Earth orbiting satellite to make sure that our urban taxi and our aircraft are all talking and communicating with each other for safety reasons. And then we come down onto the ground where we start looking at autonomy. And that becomes really interesting as you start building up autonomous vehicle stock. Then you start creating what's called this third space between the home and the office almost, where you have an extra area where you can do things, whether that's work, whether that's pleasure, entirely up to you. You're not needed for navigation. And we'll see in terms of autonomous vehicles, we'll initially see that around buses and taxis and logistics distributions, larger vehicles and those sorts of things, certainly. And also, I think as well, you'll see it on things like private roads, so mines. We've seen quite a lot on ports, for example, where you can use autonomously guided vehicles to improve unloading times because they're there exactly when you need them. But actually, towards 2030, you know, the EU have given a target of autonomous vehicles being commonplace by 2030. So actually, that third space becomes an interesting opportunity to service providers, to what they can provide in that space. And also, if we have autonomous vehicles and we have autonomous buses, taxis, and things like that, then actually sharing vehicles in whatever capacity you want to define it becomes really quite interesting, because you no longer need bus routes or taxis taking individual people. They're just vehicles moving around, picking people up in the most efficient and effective way. Because we have our city management solution, we know that person A wants to go to place X and Y. Well, if there's a person B that wants to go from Y to Z, we can more efficiently use that resource to move around the city. It becomes quite interesting and quite intelligent within that as well. So in terms of our sort of enabling technologies, you can see the percentage of electric vehicles being sold rises to 50%. Autonomous vehicles become 20%. And the importance of these two in terms of our technology piece is really around the number of sensors, semiconductors that they have on board. So an electric vehicle will have about 5 times the number of silicon chips than a traditional car. So when we have our trillion operations per second, a vehicle suddenly becomes a very strong computing resource as well. And it needs to be connected, which is where the CV2X element comes in as well. So that connectivity is not just between the vehicles, but also between the infrastructure, traffic lights, traffic management systems, all of that information coming together and working together. And now moving on to businesses. So this is really, I suppose we're coming back to our aging population, but we need new forms of productivity because we're going to face a labour shortage driven by that aging population. So it's estimated that by 2030, we'll be about 85.2 million workers short. So in order to really meet that demand, if we start in the top right-hand corner of our diagram here, things like unmanned operations really come into their own. So we are already using, in Brazil and Hungary, we're already using autonomously guided vehicles to move around our warehouses and move stock around and automatically process that stock out for deliveries. So this is certainly something that's already happening. We've already mentioned ports as well, but also industrial robots in terms of manufacturing. They're becoming cheaper, they're becoming smaller, they're becoming safer in terms of how they operate, and that you can work alongside collaboratively, safe in the knowledge that it's going to know you're there and understand to keep you safe. So I think, in terms of that manufacturing piece, certainly automation becomes really quite important as well. But picking up on the warehouse type of argument as well, that resilient supply chain really becomes important. And again, this is about taking lots of data and making sense of it. So we've noticed, certainly in the last 6 months, if you're in the UK, you've definitely noticed it, things like supply chain issues can become a real problem. Now, the world has been set up on these just-in-time supply chains, but if something goes wrong in that chain, it's a chain. One link goes, the whole chain is broken. But what about a supply network where you have multiple suppliers that can more fluidly interact? So if there's an issue in supply in one supplier, you can move to another one and more fluidly move those supplies and make sure that they're resilient moving forward as well. And then last but not least on this slide is really this notion of personalization, actually harvesting all of that data you know about your customers and allowing them to choose based on modular design, colors, types, styles of things that they want to purchase. In order to do that, you need to have a modular based design, but you also need to have an application that the person can interact with, and you need to understand what options you can and can't do to deliver that efficiently as well. And of course, going back to our supply chain, you also need a flexible supply chain, because if one particular option becomes more popular than others, it creates a knock-on effect as well. So this all starts joining up. I think that's a really important thing there. And on the left-hand side, just picking up on again some of these enabling technologies. Every 10,000 workers will work with 390 robots. Now, putting that in context, that's what, 3.9 for every 100. So that's a relatively small number. Collaboration is key here. Freeing up that workforce because we have a labour shortage, making them do things that robots can't do. 1 million companies building their own 5G private networks. And when we talk about these autonomous vehicles and ports and mines and things like that, they need their own private network because they've got very high intensity applications running, and sometimes it's because the coverage isn't there. And it's about making sure that their applications run and can't be interfered with any other sort of traffic load on the network. It's dedicated to them. Cloud services, we've almost taken this as an assumption now that things will be based in the cloud, but we haven't mentioned it up to now in this presentation. And you can see that 87% of enterprise application expenditure will be on the cloud. So the fact that the world goes all cloud is almost taken as a given. AI computing, 7% of company IT investment as well. We've talked continuously about AI, artificial intelligence, the importance of that. And that starts becoming 77% of company IT investment. So actually investing and pushing it further and further forward. So now we come on to energy. And this is, I suppose, underpinning its particular area of interest for us at the moment as we move to this, because I think there are some really interesting things that the ICT sector can do here, both within its own energy consumption and also as an enabler for others. So let's just unpack that a little bit. So the ICT sector itself contributes about 5 to 9% of the world's electricity consumption. Now, the EU has demanded that all data centers should be climate neutral by about 2030. So that's a big saving. And to give you some idea, in China, data centers contribute about 3.7% of power consumption. So, this is a noticeable saving as well. There's, in February of last year, various industry organizations, including the ITU and GSMA, came together to commit to a 45% reduction in greenhouse gases as well. So there is a lot that the ICT sector can do within itself, but there's also a huge amount that we can do to support the greenification of energy, if you will, more generally, and helping the energy sector actually meet some of these very tough targets. So on the right hand side there, we have this intelligent generation grid load storage consumption through the energy internet. You'll see the energy internet or the energy cloud referenced quite a lot. And here the idea is to create this notion of Virtual power plants is maybe a good way of thinking about it, but they become much more than that. They become hubs where information about different power sources are aggregated, whether that's fossil fuel or wind farms, solar panels, geothermal, doesn't really matter. An understanding of what power is being generated, where that needs to go through the grid, and then also combining that with the demand side. Okay, so what is the demand? What is the load? Where do we have stores that we can call upon? Where can we maybe put excess energy for now to be stored? And bringing all of that together in one system, one hub on a national basis, so that you can really start managing the power. Nothing is being wasted. Everything is being generated and stored when it can be. Anything is being consumed when it's available. So that, I think, is a really important one. And you can see there, you're going to need smart grids. You're going to need sensors in that grid. You're going to need connectivity to bring the data back. You're going to need big data in the cloud and artificial intelligence to do that in a fluid and efficient way to meet that demand. But certainly that's something where ICT can help. Another area as well, which we're seeing, which is quite interesting, is this notion of offshore power plants. So actually freeing up that arable land and the living space on land and using, how can I put it, non-solid pieces of the Earth's surface. So you see here there's a reservoir, rivers, using offshore wind farms, for example, to generate renewable electricity and renewable power. And that really becomes quite interesting. Some countries are certainly further ahead than others. Obviously, the UK, if you're in the UK this morning, very windy, wind farms doing well. But the UK and Germany currently account for 51% of the world's wind capacity. So actually, there is room. There is a lot more room for others to contribute there as well. Excuse me. So another idea is this floating solar cells. Singapore have tried this, for example, as well. So all in all, 50% of energy production will be renewable by 2030. And we think if you consider the amount of processing power we've talked about here, that's quite a significant amount. Oh, forgive me, sorry. Just take a drink. I should say at this point, I did do a negative lateral flow test for COVID before this event, so I'm definitely not suffering from that. Now, last but not least on our outlooks, we come to digital trust. Now, trust underpins all transactions that you're going to be doing. And in the information age, where information is that transaction, trust is absolutely critical to make this work. Who owns your data? Where does it go? How can it be used? What happens to it? Is it safe? Can someone get it and do something bad with it? So again, ICT, like with energy, has a big role to play in enabling that. So you can imagine things like smart contracts using things like blockchain. So as obligations are met, the blockchain just gets updated to make sure that everyone is clear on what's been done on trust. But actually, beyond trust as we see it, in terms of informational trust, this notion of privacy enhancing computation, you see it on the left there as PEC, being used in over 50% of computing scenarios. So this is this idea of privacy and data protection being baked in at source. So in terms of data collection, data storage, search, data analysis, there's some sort of privacy enhancing facilities built into the computing capacity around that. Exactly what it means varies depending on who you ask. And there are a number of different technologies being deployed, but really interesting that we talk about this notion of privacy and security being built in from the ground up. But at the same time as ICT being able to support these things with things like blockchain, PEC, etc. On the right-hand side, rules defining digital trust. We have to have, I suppose, clear set rules on how data is going to be used. So you see the GDPR there from Europe, There are 281 data breach notifications since 2018. So quite a number there. There's a huge amount of improvement needed, but it is at least flagging up that this is important, this is serious, this is something that needs doing as well. But it's not just around privacy. You know, we've seen privacy laws come in around the world, but there are also other discussions as well. Let's take AI ethics. We've talked about AI a lot, but ethics is a really interesting discussion there, and the EU has been kicking off a discussion and a debate around that, and it'll be interesting to see where that evolves as we move forward, to make sure that we know where this is headed. But there's also sort of, let's say, less obvious, less direct ways of thinking about that. So when we look at how governments around the world are starting to pay much closer attention to the large internet players, really beginning to look at what they're doing, how they control the data, some of the uncompetitive advantages that may come from owning and controlling all of that data. And we've seen that around the world, in Japan, in Germany, in China, and the US obviously has some very public investigations into that. So there's really interesting how in the digital trust world it's absolutely critical, but you need that conversation between the rule makers, the technology enablers, and actually us as end users engaging in that discussion about how that will look. So for the last couple of minutes, I just wanted to, as I mentioned, move on from our outlooks. That was the last of our outlooks in terms of the world of 2030, and just think a little bit more about the enabling technologies. We've mentioned them quite a few times, to put it politely, and you see here, you know, this is our view of that intelligent world. So all things sensing, all things connected, and all things intelligent. And underneath that, you can see those four areas. Some we've dealt with more directly, some it's just interesting to see some of these themes coming together from a technology perspective. So if we talk about and think about network requirements and what the network can mean, we have these hyper real experiences that you can see playing on the top there. Things like naked eye 3D displays, they're going to need 10 gigabits per second. So that 10 gigabits per second into the home actually isn't that extreme. It might sound it, but it's not. Digital twins underneath there, when we talk about let's say more enterprise focused applications of this, whereby you create a digital version of your assets so that you can map it, use it, and adjust it accordingly. Put these two together and you get the buzzword, I suppose, that we're hearing quite a lot around the metaverse, where we can escape into this virtual world, but it's not just a virtual world for a single game or single experience. It's actually being able to move between those experiences in a virtual way. So on the right hand side there, you can see a few of the data points that we've come up with. We've seen certainly through some of the presentation, but there's a few there as well. So if you think about average monthly data use on wireless cellular networks per person, 600 gigabytes. Currently, certainly in Western Europe, we're closer to 10 at the moment. So a huge increase as well there. The fiber broadband penetration, we saw that one earlier. Fixed data usage then goes up to 1.3 terabytes. We're kind of on about 200 gigabytes roughly in Europe at the moment. So again, you get this idea of what the demand is for the network. And in terms of those network capabilities, we're seeing sort of 6 pretty key features. If we start on the sort of top left-hand side of that hexagon there, HCS is harmonized communication and sensing. So we talked about sensors quite a lot through this, and actually bringing the sensor network and the communications network together is going to be really important as we move forward. AI native, that AI-based service awareness is really important. It's going to be a very complicated network with lots of elements. You need to actually use AI to make sure that it's able to support that, and that AI is all the way through to the edge. So it's not just in your core network to monitor some traffic. It goes all the way through, and it all works together. Security, we've talked about a lot. The deterministic experience is really about making sure that depending on what you want to do, the network will do it. So things like slicing that we're talking about now with 5G enables you to have certain parameters on a more guaranteed basis than we've ever done before. Green and low carbon, making sure that we have simplified architectures, but also as well, we've talked a lot about the energy consumption too. And a cubic broadband network, this is really talking about that notion of using all of those assets. We talked low Earth orbiting satellites. We've talked about 10 gigabyte into the home. We've talked about 5G and by 2030, 6G networks. So these will be really important and they all have to operate together. And so there's a little bit more detail on the right-hand side as well, explaining those. And computing, we talked about this a lot, and you can see those data points on the right-hand side again. Now, what does that mean? So again, if we start at the top left, we can kind of work our way around cognitive intelligence, so autonomous learning, diversified computing. So actually making sure that there's computing power everywhere. But if you're going to do that, then it has to be a unified architecture so that it can all work together seamlessly. Multi-dimensional collaboration is actually about coordinating edge, device, cloud. Again, this notion of using all of the assets available to us to deliver these services. And physical layer breakthroughs means in the hardware. So things like quantum computing and what's available there, DNA storage, for example. And then green integrated computing, really important. I mentioned about data centers earlier on. Really important to make sure that that's done in an environmentally conscious way as well. And intrinsic security goes back to this notion of built-in at all levels, that PEC we were talking about. And I won't dwell on this really. It's really talking about bringing those energy points that we were talking about earlier. So this energy cloud, energy internet we were talking about, making sure that we've got the power and we're moving it around. Vehicle electrification obviously puts more demand on that need for power as well. And the digital infrastructure, so smart grids, making sure that we can understand what's going on, where and when. And very last but not least, the car. The car as a computing platform, as an intelligent, connected platform. So you can see here what's going to be needed. For driving and autonomous driving, you're going to need sensors, you're going to need cameras moving out or looking outside. The intelligent space inside, that third space, you're really going to need to do something with the inside of a car to make it useful for the new way of functioning. Intelligent operations. So unmanned driving, yes, first in commercial vehicles, but increasingly into our cars as well. So understanding that it has the intelligence and the processing power to process that intelligence as well. So that hopefully kind of brought us full circle into the intelligent world, how we see it developing, how ICT can fit, and then into some of the enabling technologies that sit at the end. So as I've gone through, I have made a point of mentioning a few things that we'll ask some questions on at the end. If you go to the Huawei Enterprise Support Community on the link that's on there, then you can go through, and as Elena said, there's a chance to win some prizes. And Elena, I don't know if there's anything else you want to mention on that.
Just want to mention that I also shared the link here in the chat box. I will update the 3 questions in this post after you finish presenting them in the live session. So I will add the questions there in this post. You can answer the 3 questions in a comment below, and you can get a chance to win on one of the gift cards. Stephen will present the 3 questions, but before that, I would just like to tell you that 5 of the participants in today's live session also have a chance to win now, because we decided that it's important to reward those who are joining the live sessions, not just the Q&A session in the forum. So for this Q&A session, live Q&A session, the rules are very easy. all you need to do is send me a private message here in the chat box with your username and nickname in the forum. Just make sure that you send me a private message, not to everyone, but just to me. And all you have to do is, as I said, mention your nickname and username you can find in your user center. And if okay, I'm starting to. Just please make sure that the nickname or username are correct, because otherwise I will not be able to find you in the forum. And just so that you know, only external users can get rewards, so Huawei employees are not eligible for any rewards, unfortunately.
Does that include me? Sorry, just to...
Sorry, Stephen.
Oh.
I cannot give you a reward.
Oh, that's it. I'm going now. Bye.
I think it's great that I told you at the finish of the presentation, not at the start of the presentation.
Yeah, if you told me this a week ago.
Yeah, maybe I accidentally forgot. Just joking. Stephen is doing this for just to help others and to share his knowledge. He's not doing it for any rewards. So thank you, by the way, again for that.
Okay, no problem.
Okay, so once again, you can still send me your forum username or nickname through a private message here. I will announce the winners in the post when I will announce the winners of the Q&A session as well. You cannot get 2 rewards for the same activity, so you can either get the reward now in the live Q&A session or in the forum Q&A session after you answer the 3 questions. I've received, I think, some usernames and nicknames here. If there are more than 5 people who send me their username or nickname here in the chat, I will use a random selection to choose the winners. The same goes for the forum Q&A session. If there are more than 5 users who reply correctly to the questions, we will choose them randomly. Okay, thank you for sending me the. Just please make sure that you send me a private message instead of a public message. This is more for your own privacy, not for any other reasons. Okay, thank you for sending me. Now, Stephen, can you please present the 3 questions that users can reply in the forum?
Here we go. So the first question, I'm hoping actually these questions shouldn't be too taxing. If you've been following, then yeah, they should be okay. So a yottabyte of data, we said, will be generated annually in 2030. So that's a yottabyte is how many bytes? It's 1 followed by how many zeros of bytes? And you can see the options there. Is it 15, 20, 24, or 32? And in terms of question 2, what will account for 87% of enterprise application expenditure in 2030? Is it AI computing, cloud services, Wi-Fi connectivity, or robots? And final question. Yeah, this is a not question. So which of the following is not considered one of the 6 defining features of communications networks in 2030? So HCS, deterministic, or high carbon? Okay. So hopefully if you've been following the slides, they shouldn't be the most taxing thing that you've had to do today. And good luck.
Good luck, everyone. You can go here in the forum to reply the 3 questions. I will also update the questions in the forum post, but since you are here in the live meeting, you have the opportunity to be the first ones to reply these questions in a comment under the forum post. Thank you for sending me your nicknames in the forum as well. I've received your messages. We will announce the winners next week. I will just wait for maybe 1 more minute to give more users the opportunity to participate in the Q&A session. And Okay, thank you. Before we finish the presentation, I just want to thank you, Stephen, again for accepting my invitation to present a webinar for the Huawei Enterprise Support Community.
No,
I am not a technical person, but I still found a lot of interesting information in your presentation, which I think is amazing because usually I don't understand anything from these presentations. At least now I understood something. So thank you for taking the time to be a host today, and thank you all for joining today's session. Stay tuned for more live webinars in the Huawei Enterprise Support community. And if you have any feedback for me or suggestions regarding topics that would like us to approach, you can always contact me in the forum, send me a private message, and give your suggestions. We will take them into consideration and try to find the best presenters that can help us introduce that topic. So thank you again, and please don't reply to the 3 questions here. Go to the forum link I sent here in the chat box and reply there in a comment under this post, because otherwise they will not be taken into consideration. I will send the link one more time. This is the link. You have to go here and reply the 3 questions. So thank you all again. Thank you for joining today's session. Thank you, Stephen, and have a nice day, evening, or morning, depending on your time zone.
No problem at all. You're very welcome. Have a good day, everybody. Take care.
Thank you.
Bye-bye.
Bye-bye.